All right, greetings everyone. We're going to run through number 4 on page 58. Let me move this over so that I can say that. And then hopefully it'll clarify some of this because we did an example yesterday, but we were kind of stressed for time. Page 58, number 4. They said they gave you a group of numbers 4, 7, 11, 13, and 15. Okay, so far so good. And it says find the standard deviation. So at least to start with, I think it's good to use the format that they did in the example 2 that we did yesterday. So our I here is number 1 is 4, number 2 is 7, 3 is 11, 13 is 4, and 15 is 5. So the I numbers are just 1, 2, 3, 4, 5 in order, which member of the data set, and then I put the numbers in here. Now, x sub I lost my little I, x sub I minus x bar. What does that mean, Wanda? You don't have to. It's a good question. You don't have to draw this out, but I think it really helps you get organized. So if you're having trouble, it's a good idea. Okay? I think if you're having trouble, it's a good idea. So what in the heck, Wanda? I'm going to pick on you because you're Wanda. X sub I minus x bar. What does this mean? The mean. Okay. Okay. So let's figure that out. First of all, what is going to be the mean of this data right here? Megan says 10. Most likely she's wrong, but let's check her just in case. X equals, somebody else check it. Rusty? You got, oh, okay, Megan, you got lucky. It is 10. I had 2 people with 10. I have 2 people with 10, I should say. Should be proper. Kaylin? 10? Okay, if Kaylin says it's 10, then it's 10, Megan. You got lucky for sure. Okay? So it's 10. So then what's 10 minus 4? 10 minus... oh, wait. We're going the other way. It's x sub I minus... So it's the other way around. So 4 minus 10 equals negative 6. And then what's 10 minus 7? All right, do it again. 7 minus 10. Jeepers. Negative 3. 11 minus 10, 1, 13, 3, 15, 5. Okay? So then the next column over, what does it tell us to do? Square this column. Negative 6 squared. 36, negative 3 squared. 9, 1, 9, 25. Okay? And again, you don't have to use the tables, but it helps you stay organized, at least at first. Because remember, I want you to be able to do this longhand. Sarah. Minus the mean, x bar, and I should have said x bar down here is 10. So I took 4, x sub I, minus 10, and I got negative 6. And I took 7, minus 10, and I got negative 3. The last column, we take this number right here, which is x minus x bar, whatever is in that item, we square it. So negative 6 times negative 6 is positive 36. Negative 3 times negative 3 is positive 9. Okay? And thanks for asking that question. All right. So far, so good. Now we're ready to find the standard deviation. Now, what are the components of that crazy standard deviation formula? I mean, it was nutty. What are the components of that? Oop, I think I'm showing too much. I don't want to show that much. Maybe I can erase it. Okay, so standard deviation, I don't want to give it away. That would be bad. Standard deviation, we were given a formula in the book, right? And it looks a little scary. Yeah, that one. Okay? So that's the variance, and we'll do that. So keep going, Wanda. Equals the what? First of all, what does sigma mean? The sum. Good. That's the main thing. Don't get scared by all this, Megan. Just remember, that's the sum of something. We're going to add up a bunch of numbers. So we're going to add up the numbers from I equals 1 to how far? 5, because we have 5 numbers total. So I equals 1 to I equals 5, and all the ones in between. And then what are we going to add? Yeah, we're just going to add that far right column, which isn't too scary. That was just x sub I minus, I forgot my I, x sub I minus x bar, the mean. And that x looks a little ugly. I'll fix it. X sub I minus x bar squared, which looks crazy, but it's just this column. It's just this column. So when we say add up 1 to 5, here's number 1, here's number 2, here's number 3, here's number 4, here's number 5. We're just saying add up this column, okay? So let's do that now. When you add that column, what do you get? Megan says 80, and we don't believe her, so somebody check it. Okay. All right. And then over, what goes in the denominator for variance? 5 minus 1. Good, Trevor. 5 minus 1. So we put 5 minus 1 there because 5 is n, and it's n minus 1. Okay? Okay. So then, let's finish this off. Here we go. We're almost done. Esme? Okay, guys, a little buzzy still. I appreciate you doing that, but right now I need you not talking. Esme, help me out here. So we got the sum of all this is 80. Then what do we do with it? Pardon me? You do divide. So we go 80 divided by... Well, which one is it, Esme? It says 4 because it's 5 minus 1, and that equals 20. And that's the variance. Now, variance is cool, but standard deviation is the real rock star. Okay? So standard deviation is the square root of s squared, the variance, equals, in this case, the square root of 20 equals, I don't want decimal yet, I want a radical expression. Square root of 20, what do you have? No, not yet, Megan. I said with a radical simplification, what do you got? Oh, there we go. It's the square root of 4 times 5, very good, equals square root of 4 times the square root of 5 equals 2 root 5. Kobe, you are breathing a bad air. What's going on? Is this okay? All right, thanks for admitting it. Are you okay that 4 times 5, that 4 and 5 are both factors of 20, come out evenly? Okay? So I can break this up. Instead of square root of 20, I can say it's the square root of 4 times 5. And then I can break it up further and say it's the square root of 4 times the square root of 5. And then what's the square root of 4? Okay? And it is 2. So instead of square root of 4 times square root of 5, it's 2, whole number 2 times square root of 5. Which, well, then you might not be able to simplify it. And you might say, you might leave it as the square root of 21 or something. Yeah. Okay, but in this case, it's 2 root 5, which is approximately equal to what for you decimal freaks? Oh, close enough. Blah, 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 blah. Okay, that's a crude approximation, Megan. Well, it probably depends on what you're doing with it. Leave it in radical form as much as possible, but sometimes you do need a decimal approximation. And you've got to be clever enough to know the difference. When is this more useful and more informative? And when is this more useful and more informative? This is exact. This is an approximation. Sometimes this will get you in trouble if you need it in later computations. So, yeah. Okay. So that gives us the standard deviation. And again, hey, you got the same answer as the previous class. That's awesome. Standard deviation is a measure of spread. Okay? And that's just talking about how spread out the data is. Okay? Is it real spread out like this, or is it real tight like this? And it's very helpful. Because sometimes mean and median don't get you there. Okay? Alyssa, does that make sense? Is that okay? Okay. Hopefully that's helpful. Again, you don't have to use this, but if it helps you stay organized, by all means use it. All right, I will be quiet now. That is a 12 and a half minute video that I